Okay, so with the demand estimation, we'll be looking at this question. AFB Company Limited. Okay, so pause the video, go through the question, and then you follow me as I solve it. Okay. All right. So the first part, which is the A, it says that write down the estimated demand equation for your firm's product. Okay. So to write down the estimated demand equation, first, we know that quantity demand of X, okay, is a function of Px Py I, which is for income, A, and if anything follows, okay. Okay. Then we come back again. So this is quantity demand of good X, which is a function of Px, Py, I, and A. Okay, and it follows in that order. Now, since we are using statistical method, we have to quote it in the regression format, which is quantity demand of X equals beta O plus beta X and X itself, Px, that is price of X, plus beta Y and Py itself, plus beta I and I itself, plus beta A and A itself. So it follows in that order. Okay. But since we are dealing with this, so we end there. So now, with the regression method, the beta O stands for the intercept according to the question. So it stands for the intercept. Okay. And beta X here, or beta subscript X here, talks about the coefficient or refers to the coefficient. Px stands for the price. So By is also for the coefficient. Then Py itself is for the price. Now in the question, we only see parameters estimate. So if you don't see coefficient, then you will see parameters estimate, okay, or parameter estimate. Okay. So after you've quoted this in the regression format, then you come and quote the actual demand estimation. So which is starting from the first parameter, from the intercept. So it's negative 144 plus. Then the next one is what? Negative 2.5. Okay. Px plus. The next one is what? 1.25 Py plus. The next one is what? 0.20 what? I. And the next one is what? 0.06 A. Okay. So then if they ask you to write down the estimated demand equation for your firm or for any firm, So this is how you go about it. Okay. All right. Now let's look at the B. The B says that what we should test for the significance of the estimated coefficient or parameters of the explanatory variables at 5% significance level using t equals 2. Now, if you are to test for the significance of any variable in this question, mostly they will give you the percentage at which you are supposed to find. So in this case, you are supposed to use 5% significance level to find it. So if you are given 5%, the meaning you have to be given a t table, okay, whereby you have to go and locate your 0.05 on the table, see where it matches, then you use that rule to find the significance of each variable. But in the case where they don't give you any table, any t table, then you use a rule of thumb, which is the 2. So the rule of thumb, which is the 2, that is what we are going to use to calculate the significance of the coefficients, okay, of the variables. All right, so to do that, this is how you go about it. So for B, so this is how you go about it. Testing So to be able to test, first you have to define your rules. Okay. So in order to define your rules, you have to know what you are going to use to define the rules. Okay. And we are going to use the the thumb of rule, okay, which is the t equals 2, and the t calculated. Okay, so those are what we are going to use. So to find the t calculated, which is t cal equals what? The parameters or coefficient all over the standard deviation, standard error. I said standard deviation. I don't know where that is coming from. It is standard error. Okay, standard error. So to find the t calculated, which is t cal in short, it is the parameters or the coefficient over the standard error. Okay, so that is the formula for finding the t cal. Then you come and quote your rule, okay, or your decision rule. You come and quote it. So then you write decision rule. Okay. So here you say if t cal, okay, is greater than the t tab, which stands for the t equals 2, okay. Meaning the coefficient is significant. Okay, so that is if the t-cal, we use a t-cal and is greater than this 2, then it means that the coefficient is significant. Okay, but if the t-cal is less than the t-tab, okay, it means meaning the parameters or coefficients is insignificant. Okay. Okay, so this is the decision rule. And I forgot one thing. So this t here is critical value t tab, which equals 2. Okay, so the t tab, it's also critical value. So they normally represent it by t, or they say use a critical value, okay, which is t tab. Okay, you might see critical value, you might see t equals 2. Okay, it basically means the same thing. Okay, so in the case where you are not given the t table, this is what you'll be using. Okay, so you state the t calculated, which is t-cal equals coefficient over standard error. Then your critical value, which is this, which is the thumb of rule. Okay, the thumb of rule is a t tab, which equals 2. Okay, then you come and define your decision rule. So now that we've defined the decision rule, then you draw a nice table. Okay, so starting with the first independent variable, which is the px. So we write here variables. So px, then we have py, then the next one is I, which is income, then A stands for advert. Then comes your parameters. So it's parameters or coefficient, okay? The same thing. So from the question, this one is negative 2.5. Okay, this one is 1.25. This one is 0.20. And this one is 0.06. Okay, so after that, then you come in. After that, you bring your standard error. Okay, so S error, let me write it in short. So your standard error according to this question is 0.98261. Then we have the next one to be 0.0242. Then the next one is 0.3685. Then the next one is 0.0224. All right, now that you are done, then you come to your t-cal. Okay, your t-cal, this one. So the t-cal, to find the t-cal, it says that we are using the parameters over standard error. Parameters, which is the same as the coefficient here. So you can do your workings somewhere. Okay, so the first one, let's do it somewhere. then we will input the figures. So it is negative 2.5 divided by 0.98261. Okay. So we had 2.54, negative 2.54. Okay. Then we go to 1.25 divided by 0.3685. So that one too, we had 3.39. So they are all at 2 decimal place. Okay, 2 decimal place. Then the next one is 0.20 divided by 0.3685. Okay. So that gives us 0.54. Then the last one, 0.06 divided by 0.0224. At 2 decimal place gives us 2.68. Okay. All right. Okay. Sorry, I think I made a mistake here. Let me do it again. So 1.25 divided by 0.0242. So that should give us 51. So 51.65. Okay. 6.5. All right. So now that we are done with the tcal, okay. So make sure you open your eyes as you are solving. Okay. Limit your mistakes. Well, it's night here and it's 12 a.m. at the moment, so I'm kind of feeling sleepy and tired at the same time, so forgive me. All right, so the next one is your t-tab. Okay, your t-tab. Now the t-tab has already been given you, which is 2, and that is constant throughout. Okay, it doesn't change. So now we have our t calculated and our t-tab. So here is our decision. So you can see, so we have the variables here, we have the parameters or the coefficient, we have the standard error here, then the tcal. How did we get the tcal? Is the parameters over the standard error, which gives us the tcal. Then the t-tab is already given to us, which is the critical value, and it's constant throughout. Okay, so now what we are going to do is we are going to compare the tcal and the t-tab based on the decision rule that we stated here. So we say that if the tcal is greater than 2, then it means that the coefficient is significant, right? So we need the absolute, we are using the absolute figure of 2.54, okay, not the negative. Okay, so ignore the negative here. So we are using the absolute figure. So 2.54, okay, and 2, which one is greater? So realize that 2.54 is greater, right? Which means that px is what? Significant. Then py, here we have 51.665, which is way greater. So this one too is also significant. Then I, so comparing the I, realize that this one is 0.54, which is less. Okay, is less than 2, which means this one is what? Insignificant. Then we have 2.68, which is greater than 2. So this one is significant. Okay, so this is our nice table. Now that we are done, then we come and conclude. So you write okay. So conclusion. Okay. So with a conclusion, this is how you state it. You say that all the variables, okay, px, py, and a are what? Significant. So all the variables px, py, and a are significant, except I. So all the variables px, py, and a are significant except I, okay, which is insignificant. Okay, so that is how you quote it. Okay, all right, so now let's move on to the next part, which says that we should interpret the coefficient of the significant variables. Okay, so to interpret the coefficient of the significant variable, which is the c, okay, so we start with the px. So you say px colon, then you write a unit change in px, okay, will lead to a change in quantity demand. Okay, quantity demanded into brackets q dx. Okay, so a unit change in px will lead to a change in quantity demanded by, then you quote the units, okay, 2.5 units in the opposite direction, comma, all things being equal. Okay, so this is how you interpret it. So a unit change in px, okay, so we know what px means according to the question, will lead to a change in quantity demanded, which is q dx, okay, by 2.5 units in the opposite direction. Why is it the opposite direction? Because the parameters or the coefficient is negative. Okay, so if it is negative, it's in the opposite direction. Okay, if it is positive, it is in the same direction. Okay, so in the opposite direction, all things being equal, finish. So you are done with that. Then you go to the next one. So you pick py, okay, which I have to use the next section. So let me just shift everything and pause this. All right, so I've cleared the table to make space. So let's continue. So the next one is py, you put colon. So you say a unit change in py, okay, so change will lead to a change in QDX, okay, which is quantity demanded, by, then you quote the unit, okay. So this PY was, according to the, by 1.25 units in the same direction, comma, all things being equal. Okay, so this is how you also interpret the PY. Okay, then we also interpret the A, which is the advert. Now, read the question very well. The question said that we should interpret what the coefficient of the significant variables. Okay, and already we found the significant variables. So from the beginning, we realized that Px is significant, Py is also significant, but I was insignificant, and A was also significant. So the question says that we should interpret the coefficient of the significant variable. So we are interpreting only the significant variable. So which means that I wouldn't be interpreted, okay? So we skip I and go to A, okay? So we've already interpreted the Px, we've interpreted the Py. So now we'll interpret the A2. So A unit change in A, okay, which stands for advert, will lead to a change in So for this one, the coefficient is 0.06 units in the same direction, or things being equal. So we are done with the interpretation of the significant variables. So now the next question for the D. Okay, D says that what? We should determine the quantity of bedrock fertilizers bought by consumers. Determine the quantity of bedrock fertilizers bought by consumers. So to do that, we first have to quote the demand equation, which is Q dx, which equals is -144 plus minus 2.5 px plus 1.25 py plus 0.20 I plus 0.06 A. Okay, so this is negative. This is negative. All right. So to determine the quantity of bedrock fertilizers bought by consumers, so we go to the question and read the additional information that we have there. So it says that now suppose 2 bags of bedrock fertilizer is sold for 40 cedis. Okay. A bag of Asasira fertilizer is sold for another 40 cedis. The per capita income of cocoa farmers is 750. Then the company spends 800 on advertising. Okay. So we have to input this data into it. But realize that they said that suppose 2 bags of bedrock, okay, fertilizer is sold at what? 40 Ghana cedis. Okay, so before you be able to determine the quantity of fertilizers bought by the consumers, you should be able to get the per unit price for um bedrock fertilizer. Okay, because all the remaining uh, factors are in per unit or for a bag. Okay, but it's only bedrock that is 2 bags. So you should also take note of that. So for that, we can do it somewhere. Um, so let's do it here. So we say, okay, never mind. Let's just put in the data and we do it within it. So it's -144 minus 2.5. Okay, you open bracket. Now it is 40, okay, divided by 2, bracket close, plus 1.25, open bracket. This is also 40, right? Plus 0.20, open bracket. Now income is 750, okay? So 750 plus 0.06. Advertising is 800. Okay. So you put in the value and then you use your calculator to find the demand for bedrock fertilizer. Okay. So let's put in everything. Okay, so we put in everything and we had 54. Okay, so to avoid stress doing it one after the other, you just put in everything and you get. So the quantity of bedrock that consumers normally buy is 54. Okay, so you can put, therefore the quantity that consumers buy is 54. Oh, so you let me write it. So therefore, okay, so that is for the D. Okay, so we move to the E. Now, the E says that we should estimate the own price elasticity of demand and state the type of demand curve. Estimate the own price elasticity of demand and state the type of demand curve. Okay, so to do that, you first have to quote the own price elasticity of demand formula, which is OPED equals change in QDX over change in price times price over QDX. Okay. All right. So now that we have our formula, we just substitute in the values. But you should know, when you are solving an elasticity question, you will need an initial price and a current price, or an old price and a new price, an old quantity and a new quantity to find a change. Okay. But in this question, we don't have anything like that. So in order to arrive at that, we have to differentiate. Okay. So this is where differentiation comes in place of the change. Okay. So in this case, it's going to be equal to d what? QDX over differentiation of px times px over qdx. So what this means is that we are going to take the equation, okay, and differentiate px from the equation. Now, this is what I mean. So let's quote the equation, so which is okay. So I don't know why I'm mixing this. So qdx equals negative 144 minus 2.5 px plus 1.25 py plus 0.20 I plus 0.06 A. Okay. So now, when we are differentiating, so this is quantity, right? So in quantity, we are differentiating px from the equation. So what it means is that within this quantity function here, so these are the factors that affect quantity. So within this quantity demand function, okay, we should go through this and find px. So wherever px is, we differentiate it, okay? So we'll look at differentiation in another day, okay? So anything that is not px related, we discard it. So we quote, so this time we will bring the differentiation. This is differentiation of q dx, okay, over differentiation of px. So we'll look at this first value here. Does it contain any variable like px here? No, it's just the value here, so we discard it. What about this one? Yes, so this one is negative 2.5 times px, or negative 2.5 px. So this has a px element in it, so we differentiate it. So if you differentiate px out of this variables, you are going to be left with negative 2.5. Okay. All right. Now let's go to the next one. Is px here? No. So we discard. Is px over here? No. We discard. So is px over here? No. So we discard. So at the end of the day, we are left with negative 2.5. Okay, which represents this. So we differentiated px out of it to get this negative 2.5. So now that you've gotten this, the formula says that this, your differentiation answer, you multiply it by px over q dx. Okay, so this is the answer for the differentiation that we did. Okay, so we have to multiply it by px over q dx. Okay, so to do that means that this implies that what 2.5 times. Now they've given us px. Okay, they said px is what 20 over here. So when you divide it, so a bag is what 20. So 2.5 times 20 over. Now what is the quantity demanded of bedrock is 54, right? So you come and put 54 here. I hope you are following. Okay, so this is how it's going to be. Then you just input everything into the calculator. Okay, so that you don't waste time. So it's negative 2.5 times 20 divided by 54. So you're going to get negative 0.925, but we only want the absolute figure. So absolute 0.926. Okay, so you can leave it like this. All right. So the question says that we should estimate the own price elasticity of demand. So this is the own price elasticity of demand. And we should state the type of demand curve. So based on this answer that we've gotten, what kind of demand curve are we going to get? Okay. So for elasticity, we have a rule. Okay. The rule is that the answer that you get, okay, from calculating elasticity, own price elasticity. Okay, this one. Okay, sorry. Let me bring it forward. So the answer that you get from here, okay, you are supposed to compare that answer with 1 to see if it is either greater or lesser or equal to. So if it is greater, okay, then we say it is elastic. That is, if it is greater than 1, we say it is elastic. If it is less than 1, we say it is inelastic. And if it is equal to 1, we say it is unitary. So in this case, it is 0.926, which is less than 1. So which means it's an inelastic curve that we are going to get. Okay. So you will say that the demand curve is an inelastic curve. Okay, since its elasticity, since its price, okay, price elasticity of demand, which is 0.926, okay, is greater, is lesser than 1. Okay, it's night time and I'm feeling a little bit sleepy, so forgive me. So this is less. Okay, so it's inelastic. Okay, so then you are done. So that is the answer for E. Okay, then we go to F. F says that what would be the firm's pricing policy option? So let me adjust. So F. So the pricing policy, what do you think the firm should do based on the answer that we've gotten? Okay, so over here, you are only to state. So you can say since the since the demand since the demand since the demand curve is inelastic. Okay. So I'm using curve because that was what the question said. Okay. So that is why I'm using curve. But mostly it is since the demand mostly you would say since the demand of bedrock is inelastic. Okay. So you can equally use that as well. Since the demand of bedrock was its own price elasticity. So we are looking at the price of bedrock. Okay. So I'm using demand because it's in the I'm using curve because it's in the previous answer that I gave. So since the demand of bedrock or since the demand curve is inelastic, okay. So the firm should increase price to maximize revenue. So that should be the policy of the firm or the pricing policy of the firm. Okay, they should increase their prices to maximize revenue. Why is it so? Okay. It is so because when you have an inelastic demand, it means that a greater change in price, okay, only leads to a small change in quantity demanded. Meaning, no matter how wide the margin of price is, okay, the changes in um, consumers, whether they are going to buy less of it or more of it, is very small. Okay. So if you increase your prices, those that will stop buying will be just one or two people, it will just be few people. Okay. So in that sense, you'll be making more profit. Do you get it? So that's the reason why when you have an inelastic demand curve or inelastic answer, it is advisable that you increase prices in order to what maximize your revenue or increase your revenue. Okay, so that's the explanation for that. So that's the answer for F. Then we go to G. So the G says that we should assess the probable impact on the firm or on your firm if Yara Ghana decreases the price of Asasura fertilizer by what? 8%. Okay, so to answer that question, this is how you go about it. So because Asasura, okay, is a competitor in the market, so Asasura is also competing with Bedrock. Okay, so because Asasura is a competitor, you first have to find the cross price elasticity of demand, okay, for Asasura. Then you look at finding your 8%. Then you see the impact, okay, on Bedrock if Asasira is to decrease their prices. Okay, so this is how you go about it. So it is cross price elasticity of demand. Okay, that is what we are using because we don't have an initial price and a current price for Asasira. Okay, so in this case, we are supposed to differentiate. Okay, so let's differentiate directly. Okay, so CPE ED equals the differentiation of q dx over py times py over q dx. So we are differentiating the quantity demand of X, which represents bedrock, okay, to the price change in Asasira, okay, which is the competitor, which is PY, okay. Now I've shown you how to differentiate this, okay. So you take the equation, then you look through to see wherever PY is, then you differentiate. If PY is not in the equation, is not among the variables, okay, you discard. Okay, so that is how you go about it. So if just you look at the first one, the way I did it, then you follow the same. So if you do that, you are going to get so if we differentiate it, you are going to get 1.25 as the answer. Okay, then you multiply that by the price of Asasira PY. So PY in the question was 40. So 40 over the demand, and demand was what? 54. Okay, so we input that in the calculator. So 1.25 times 40 over 54. And we have 0.926. Okay, 0.926. Okay. So now that you've gotten your cross elasticity, so the question says that when Asasira, okay, decreases, so decreases by 8%. Okay, so this 8% is negative 0.08. Okay, all right. So then, since we've converted this decrease, okay, of percentage to its decimal, then the next thing is you quote the impact that this decrease is going to have, okay, on the cross price elasticity answer that you've gotten. So it's going to be change in QDX, okay, over negative 0.08 equals 0.926. Okay, do you get it? Okay, I hope you've gotten it. All right, so now we do cross multiplication. So this multiplies this multiplies. So this is over 1 automatically, okay. So when we do cross multiplication, so it's going to be negative 0.08 times 0.926, which equals what? Change in what? QDX. So then we use a calculator. So negative 0.08 times 0.926. That gives us negative 0.07408. Okay, which equals change in QDX. So let's just interchange it. So I'll bring this one here. So the change in QDX equals what? Negative 0.07408 7408. Okay, so this answer, I'll multiply it by 100 because we need it in percentage to find the impact. Okay, so you multiply this answer by 100. So if you multiply it by 100, so your answer times 100, you are going to get -7.408. Okay, so we don't actually need the negative. Okay, so we convert it to percentage, just like the way we did this. Okay, it's a decrease. Okay, so we understand it's a decrease, but we don't need a negative because you're converting it to um, percentage. So it's going to be 7.4 what 08%. Okay, and this represents the impact. So after that, you can quote. So this is absolute. Okay, this is absolute. So you can quote that a decrease in price of is asasira. Okay, asasira fertilizer. Okay, who is a competitor, will lead to a decrease in the quantity will lead to a decrease in the quantity demand. Okay, quantity demand of bedrock by 7.408%. So this is how you conclude. So a decrease in price of asasira fertilizer will lead to a decrease in the quantity demand of bedrock by the percentage. Okay, so that is the impact, okay, of a decrease in asasira to bedrock. So if asasira is to decrease their prices by 8%, the quantity demanded of bedrock will also reduce by 7.408%. Okay, all things being equal. All right, so that is for the G. Then we'll go to the last part, which is the H. The H says that we should what? Interpret the adjusted R squared. So now the adjusted R squared in the question, okay, it represents the importance of the independent variable. Okay, so we could have used the R squared. Okay, in normal regression is R squared, but we are using the adjusted R squared, okay, because we don't want to overestimate the importance of the independent variables in the question. Okay, so that is why we are using the adjusted R squared. Do you get it? So how then do you interpret it? So this is how you go about it. Sorry, the book shifted, so I have to readjust it. So this is what you're going to get. Okay, this is what you're going to get. So now we are on the R squared. So this is how you explain the R squared. So you say the adjusted R squared, which equals, okay, so the R squared, the adjusted R squared is 0.0 8947. So the adjusted R squared implies that the variables which is the independent variables, okay? The independent variables, so put here independent. Independent variables explains what about is 89.47%. Okay, so you multiply this by 100, okay, because you want it in percentages. So you multiply this value here by 100, okay. So if you multiply it by 100, you're going to get 89.47. So the independent variables explains about 89.47 of the variation in the dependent variable. Okay, so the adjusted R squared, okay, which is 0.8947, implies that the independent variables explains about 89.47% of the variation in the dependent variable. Finish. Okay, so that's all for this question. Okay, it's late and sorry for the mistakes and all that, but I hope you understood it very well. Okay, so if there's any part you don't understand, you can contact me and I'll explain. I'll give you much explanation. Okay, so this aside that, I would say I'll catch you on another topic. Okay, but then I'll post an assignment so that you can try your hands on it. Okay, so until then, see you on another topic. Bye bye.